Lesson 7.2 is on scientific notation, and your learning target today is to write and compare numbers in both scientific and standard notation. So in order to do that, you're going to have to know what both of those mean, and that's what we're going to look at today. As usual, you can set your paper up for Cornell notes. This is lesson 7.2. A good way to abbreviate scientific notation is just sci not, and that's a pretty standard way to abbreviate. Write in the essential question based on this learning target, hit pause, and then resume when you're ready to go. Okay, for the first part of this, you should not write anything down, just watch. This is just a review and to bring some things forward that you already know, but to make sure that you understand them for today's lesson. Powers of 10 are just numbers 10 with an exponent. So 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, all the way to the 10 to the seventh, and so on. Those are powers of 10. And what it means when you have a power of 10 is just to multiply 10 by itself the number of times in the exponent. So 10 to the first is 10, 10 to the second is 10 times 10, and so on. If you did lesson 7.1, you already know this because you were asked about these kinds of powers in 52 through 56, I think it was. And what you should notice is whenever you have a power of 10, the exponent, 1, 2, 3, 4, 5, 6, 7, will actually give you the answer without having to write out this multiplication problem. Because 10 to the first power is 10, that's a 1 followed by 1 0, 1 0. 10 to the second is 100, that's a 1 followed by 2 zeros, and so on. So 10 to the seventh without any multiplication or any thinking is just a 1 followed by 7 zeros. So if I were to give you another one, 10 to the 12th power, you don't have to multiply 10 times 10 times 10 times 10 and so on. You just write a 1 followed by 12 zeros. 3, 6, 9, 12 zeros. Pretty easy. Still, you don't have to write this down. Now if you take a decimal number like 2.3 and you multiply it by some power of 10, the trick that you should have learned way back in grade school is this number of zeros tells you how many times to move the decimal point. So 2.3 times 10, I have 1 0, I'm going to move it one time and get 23. And 2.3 times 100, there's 2 zeros, I'm going to move it 2 times. Any empty space that I have, I'm going to fill with the 0, so I get 230. 2.3 times 1,000, 1, 2, 3 zeros. I move it 1, 2, 3 times, fill the empty spaces with zeros. That's 2,300. One more. 1, 2, 3, 4 zeros. 2.3 times 10,000. I move it 1, 2, 3, 4 times. Fill the empty spaces with zeros. That's 23,000. That's just a trick that you should have already learned a long time ago. Now if I take these powers of 10, 10, 100, 1,000, 10,000, 100,000, and so on, and rewrite them as exponential numbers, 10 to the first power, 10 to the second power, 10 to the third power, it's even easier because now I don't even have to count the zeros. This 3 tells me to move it 1, 2, 3 times. This 4 tells me to move the decimal place 1, 2, 3, 4 times. So 2.3 times 10 to the 5th is 2.3 times, move it 5 places. 1, 2, 3, 4, 5. Fill the empty spaces with zeros. I get 230,000. Okay, all of this is just to lead you up to scientific notation. So this is the first thing you should write in your notes. This is just a definition of scientific notation, and here it is. Really, really big numbers or really small numbers get to be kind of cumbersome or kind of difficult to write over and over again. So scientists developed a notation to help them. All you do is write one digit followed by a decimal point, followed by 2 other digits, and that's multiplied by some power of 10. Now if you don't get what I'm saying, that's okay, just write it down. And here's what it means. Let me back up. So, if I have a big number like 367 million or more, this is a really big number. I can write this number in scientific notation just by putting the first digit, then a decimal, and the next 2 digits multiplied by some power of 10, and in this case it's 11. That's a scientific notation number. And instead of having to write out all the zeros, I'm just writing it out as a decimal number times the power of 10. What gets confusing sometimes is you have to have a power of 10, and there has to just be one digit followed by 2 others with a decimal point in the middle. Okay, so if we look at the first problem, the question is, are these numbers written in scientific notation? So copy these numbers down, A, B, C. Copy the problems down. And look at the first one. Is the first number written in scientific notation? The answer is no. One thing I didn't mention, the first digit has to be something other than 0. So this first one is not in scientific notation because the first digit has to be something other than 0. If this were written like this, then it would be in scientific notation. Look at the second one, 2.3 times 10 to the 7th. Here's another thing I didn't mention. If there is no third number or second digit after the decimal point, that's okay. It's kind of implied to be a 0, so this is written in scientific notation. You could just add the 0. And now look at the last one. 9.3 times 100 to the 9th. This is not written in scientific notation. The first part is okay. The last part is not a power of 10. That's written as a power of 100. That's why it's not scientific notation. Moving on. So in order to write a big number or a small number in scientific notation, there are some steps that you follow. Now I know that you learned this in math class last year, so this should be reviewed, so I'm going to go kind of fast, but if you get lost, stop, rewind, and watch it again. In this big number, 3,560,000,000, the decimal point isn't in the number, but it's implied to be at the end. So anytime you have a big whole number, always put the decimal point in at the end of the number. To write this in scientific notation, what I really want is for the decimal point to not be at the end, but I want it to be right here. So the blue stuff that I'm writing, this is the same stuff that you should be writing on your assignment when you do these problems. Here's where the decimal point is to begin with. Here's where I want it to be. In order to get the decimal point from this point at the end to this point where the arrow is, I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So the scientific notation for this number is 3.56 times however many times I moved the decimal point from where it was to where I want it to be, and that was 9. And that's it. Now notice that this is a really big number. When you're writing really big numbers in scientific notation, the exponent on the power of 10 will always be positive. A big number equals a positive exponent. Look at the second one. 0.0000000000684. That's a really small number. And here's the decimal point, so I'm going to make it exaggerated. The decimal point is currently sitting right here, and I want it to be right between the 6 and the 8, so that I get a scientific notation number that looks like this. So I have to move it from here at the left hand side to here where the arrow is. How many times does it take me to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my scientific notation number for this really small number is 6.84 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 10th power. But because this is a really small number, it's negative 10, which tells me I've moved the decimal point from the left to the right. So when you have a small number, the exponent is going to be negative. Okay, so what is each number written in scientific notation? Well, all that I've done here is given you problems that give you actual distances that you might find in science. The approximate distance between the Sun and Saturn is 1,430,000,000 kilometers. You can write this number in scientific notation. So on your paper, this is problem 2, this is part A. I'm just going to write 1,430,000,000. This is a really big number. It's a really big whole number, and at the end of every whole number is where you'll find the decimal point. And where I want it to be is between the first and second digits, non-zero digits. So I have to move it from the right-hand side to where the arrow is. How many times does that take me to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this number written in scientific notation is 1.43 times 10 to the 9th, and that's kilometers. That's it. Notice the exponent is positive because the number is really big. In the second part, part B, it says the radius of an atom is 0.00000000001. So I write out B, 0.0. Now you can write the 0 at the beginning, but it's not totally necessary. 0, 0, 0, 0. How many zeros did I say? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The decimal point is right here, and I want it to be after the first non-zero digit. So I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 times 10 to the 10th, but this is a really small number, so it's negative 10. Now look at the first part of my scientific notation. Where's the rest of it? Well, with decimal numbers, it's okay to add zeros at the end. It doesn't change the value. So I'm just going to add in 1.00. And that is the radius meters of an atom in scientific notation. So here are a few other examples. You can try these, and at the end I'll come back and show you the answers. So if you want to stop and write these out and come back later, or resume when you're ready. Okay, if I have a number that's already written in scientific notation and you want to write it in what's called standard notation, here's the way you do that. Now standard notation just means the way you normally write a number. The number 42 is standard notation. The number 109 is standard notation. That's just the way you write a number. So 7.92 times 10 to the 4th represents a really big number. How do I know that? Because the exponent on the power of 10 is positive, which makes it a big number. So the way I change this number from scientific to standard notation is I start by writing the first part, 7.92. I'm going to move the decimal point on this part of the number 4 times. This is how many times I move the decimal point. In order to make this number bigger, which way do I move the decimal point? To the left or to the right? Well, the answer is to move it to the right. 1, 2, 3, 4 times. That will make it bigger. Anytime I see an empty space after moving the decimal point, I fill it in with a 0. So this work that I'm showing you in red with the little loop-de-loos is the work I should see on your paper when you're doing your assignments. Now that you've moved the decimal point, it's hard for me to tell whether you've moved it left or right. So when you're done, rewrite the number without all the loops. And that's your final answer. Here's the second one, 6.48 times 10 to the negative third. The negative 3 tells me it's what kind of number? A really small number because the exponent is negative. So I start by writing 6.48. The 3 tells me I'm going to move it 3 places, and the negative tells me I'm going to make it a smaller number. And the way you make a smaller number is to go backwards. 1, 2, 3 times. Any empty spaces are filled in with zeros. I've moved it, I've written in the loops, so I'm going to rewrite it so there's no extra stuff. And that's my answer. So here's another example. What is each number written in standard notation? The weight of an Asian elephant is 5.5 times 10 to the 6 grams. 10 to the 6th. The 6 is positive, that means it's a really big number, so I start by writing 5.5. I'm going to move the decimal place 6 times. 1, 2, 3, 4, 5, 6. Fill in with empty spaces. Rewrite it so there's no extra stuff. And that's got a label on it, grams. The second one, the weight of an ant is 3.1 times 10 to the negative third grams. The negative 3 tells me it is a small number. So I write 3.1, and then I move backwards 3 times. 1, 2, 3. And then I rewrite it, 0.0031 grams. And that's it. Now, a common mistake with scientific notation is some people will look at the exponent, like this one, 6, and they'll just add 6 zeros. 1, 2, 3, 4, 5, 6. Is this answer the same as this answer? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, 6 zeros. No, you're not just adding zeros, you're moving the decimal point. So make sure that you get the whole process down.